So this is a circuit that we're going to have to be dealing with. All right, so this is the circuit. So looking at the direction of our current, this will be our first equation. Okay, so here you see that this place is negative, this place is what? Positive. So because my loop is going this way, always the current will flow from the positive and then to the negative. So here become positive and then what? Negative. Okay, and mind you, whenever you have the loop and the current in the same direction, that means there is a voltage drop in that particular resistor. The voltage there in that resistor will be negative. If they are in the opposite direction, that means that there is an increase in voltage and that particular voltage will be positive. So now first, in this particular resistor, you see that the current and the loop are in the same direction. And also, you can see that the current is starting from the positive and it's coming to the negative. That means that the voltage is decreasing. That's a voltage what? Drop in this particular resistor. But when you come to this voltage, you see that it's from the negative, it's increasing to the positive. So this voltage here will be what? Positive. Okay, so then here here will be what? Negative. So minus what? 10 into what? I1. Here from positive to negative, that means it's what? Decreasing. Okay, or the loop is in the same direction as the what? Current. That means there's a voltage drop, or voltage is what? Decreasing. So minus what? 40 I what? 2. This is equation what? 2. All right, now let's take this one. So because the loop is moving this way, here will be what? Positive, here will be what? Negative. So here you can see that the direction of the current and the loop are the same. That means that there will be a voltage drop, or the voltage is from positive is decreasing to negative, so there will be a voltage what? Drop. Okay, why am I putting here to be positive, here to be negative? I'm putting here to be positive because you can see that I'm starting my loop from here. Okay, so when the current is passing here, before it goes here, then here will become positive, here will become what? Negative. Okay, so here you see that it is the loop is starting from here and it's coming here. It's starting from here, it's negative, it's increasing to the positive. So this one will be what? Positive. So I'll write positive 40. Okay, I2. Here is negative, I told you. So minus 20 I3. So here you can see that here is what? Positive. Here is what? Negative. Is decreasing because from positive to negative. So negative 20. Okay. Please here I must put 0 is equals to what? 0. Equation what? 3. Let's say equation 1 into 1 into 2. So if we should simplify this one, we will have so this is equation 4. Okay, so now 4 So we get I2 to be 0.268 amps, okay? That's what we get I2 to be. So now I2 into equation 4. We get I3 to be equals to minus 0.415 amps. Okay, so now I2 and I3 into equation 1. So I1 will be equals to minus 0.129 amps. Now let's see if our solution actually works for our circuit. So this is the circuit. So let's find the voltage drops across the various resistors. So now let's see the 10 ohm resistor, the voltage drop across it. So you have 10 times I1, which is the current passing through it, and I1 is minus 0.129 amps. So we will have 10 times 0.129, which will be equals to negative 1.29 volts. So the voltage drop here is negative 1.29 volts. So that means that 10 minus 1.29 volts. So that means that 10 volts, this 10 volts minus this 10 volt minus this one, okay, or minus 1.29 volts, which will give us 11.29 volts. So that means that this place will be 11.29 volts. This place, this point will be 11.29 volts. Okay, all right. So now let's find the voltage across the 40 ohm resistor. So 40 times here, the voltage here is I2. Okay, the voltage here is what? I2. So I'll write I2 here. And this one is I3. Okay, this is I3. So here is what? I3. Okay, so the voltage across the 40 ohm resistor, so that will be 40 times I2. The voltage, the current through the 40 ohm resistor is I2, and I2 is 0.286. So 40 times 0.286 amps. So which will give us 11.44 volts. So that means that the voltage drop here is 11.44 volts. Okay, so you see that the voltage here is what? 11.29, and here is 11.44. Okay, they are approximate, they are the same, but because of the decimal places that we are rounding off, that is how come we have a small difference. So they are the same. Okay, they are approximately the same. So that means that if you subtract this 11 from this 11, okay, here will become what? 0 volts. If here is 0 volts, there is no load here, so there is no voltage drop here. So here will be what? There is no voltage drop here. So that means that here also becomes 0 volts. Okay, so that means that the sum total of the voltage in this loop is what? Is 0 volts, which is correct according to the which makes our work correct according to the Kirchoff's closed loop rule, which says that the sum voltage, the sum of the voltage in the loop must be 0. So here we got the sum of our voltage to be what? 0. Okay, all right. Now let's come to this particular loop also. So let's see this 20 ohm resistor. What is the voltage across it? So it will be 20 times I3, and I3 was negative 0.415. So negative 0.415 watt amps, which is equals to. Okay, so the voltage drop here will give us negative 8.3 volts. So the voltage drop here is negative 8.3 volts. Now, if you can see, here is what? 11.29. So 11.29. So here is negative. That means that minus what? 83. Okay. Okay, so that means that the voltage here is approximately 19.6 volts. Okay, so that means that the voltage at this point is approximately what? 19.6 volt, 19.6 volt. So here you can see that is negative and is decreasing to what? Is positive and is decreasing to negative. So this voltage is what? Negative. So if you subtract this 20 from this 19.6, okay, it's approximately 0. We're supposed to get 20 here, but because of the decimal places, that's how come we're getting 19.6. But if not because of the decimal places that we are rounding off, here would have been 20. So this 20 minus this 20 will give us here to be what? 0 volt. So that means that our solution is what? Correct. Thank you very much.